external HIUs. Tom Burton, who will be leading on this, I'm just going to flag up for him. He actually presented to the 40H conference in Denmark last year, the findings from his research on the grad project. So I'll hand over now to Tom Burton, consulting engineer at FairHeat, and to Clare Murray, who's head of sustainability at Levitt Bernstein.
Thank you, Gareth. So I'm going to kick today's session off by just talking a bit about external HIUs and the research project that that ran for about kind of 6 to 8 months throughout 2019 and 2020. So to start with, I'll just talk about the few of the main issues that we see with the current network configuration, and then go into a bit about how external HIUs can the solutions that these enable and how these can resolve these issues. Then before I go into a bit more detail about my research project and the findings from that, Claire's just going to give us the architect's view on external HIUs, the challenges that you can face by implementing it, and what can be done to overcome these. So before we start talking about the issues, this is a schematic that should be kind of familiar to most people. This is what networks typically look like currently. So you've got the one riser running up the kind of one riser per building per core, and then you've got these long laterals on every floor, and HIUs are located internally to flats, kind of typically in utility cupboards. That's what things currently look like. The temperatures we've now managed to drop these down to kind of 55, 60 flow, 25, 30 return. That has been spoken about in the first session, and there'll be some more information about it in the third session as well. But what I want to focus about here is this side, the building side, and the network routing options that you have. The first main issue, the title might have given this away a bit, is accessibility of HIUs, and this really boils down to the fact that to maintain performance from handover throughout your network lifetime, you need to be regularly servicing HIUs, and this can't just be most HIUs. It really has to be 100%, because a very small number of poorly performing HIUs can really have quite a significant impact on network performance. And whilst before this has just been a performance thing with new GLA regulations coming through, the B scene specifically, developers are going to have to start proving efficiencies in use, and this is going to be over a number of years. So this maintaining performance is not just going to be an operator's issue now. It's going to be really kind of developers as well going to have to start thinking about this a lot more. With the HIUs within dwellings, you need cooperation from residents in order to gain access, and this is a difficult and lengthy process, and as a result that means it's quite expensive as well, and this means that 100% service level is really quite difficult to achieve in practice. And what we also see sometimes is that some residents are also responsible for maintaining their HIUs, which means you've got third parties maintaining the system who don't know anything about how the system has been designed to operate. They don't know kind of set points of the network, the hot water, space heating, and sometimes also the training levels aren't quite as good as what you would get from a qualified kind of HIU servicing engineer. To give an example of the impact that accessibility can have on a system, this is a case study of project we worked on. It's a 140 unit scheme, and this graph is of the block level heat meter. So you've got the flow temperature in dark blue, the return temperature in green, and the flow rate of the system in light blue. And you can see, so on the left hand side you've got about a 70 degree flow temperature, and the return temperature is sitting about kind of 60, 65 degrees, so really quite elevated. And then you can see in the middle, about 8 o'clock on the 20th of March, this was a couple of years ago, one bypass which we'd identified through remote review of the data, we found that all of these performance issues were caused by this one bypass above an HIU. That got closed, and almost immediately the flow temperature dropped by about 25 to 30 degrees. So it's really just quite a good illustration of just how much an impact each HIU can have, and kind of really reiterates the point that you need to be getting to 100% of these. The other main issue that we see with the current configuration is the overall length of the network, and quite kind of more specifically the terminal run. So this is the pipework within dwellings. And whilst kind of when you're in a flat, it doesn't look like a significant amount of pipework across the entire development, pipework in dwellings is about 50% of your overall network length. And this constrains your losses to a minimum, even if you optimize from a temperature perspective, from an insulation perspective. Really, kind of the best you can hope for is about 90-ish watts per dwelling heat losses. And CP1 2020, which is also mentioned quite heavily throughout the first session, that's going to require networks to have calculated heat losses of below 100 watts per dwelling. So this current configuration really doesn't leave you that much flexibility in your design, and you really have to go quite kind of heavy on the insulation and on performance to make sure that you can stay within that performance metric. And this is also going to be incorporated into the heat network market frameworks, or is likely to be, which again was spoken about during the first session. And this means that this could be, this may end up being a regulatory requirement to design to meet this 100 watts per dwelling. And again, with the internal HIUs, that is possible, but is difficult. Sorry, Gareth, can you put the next slide on, please? Great, thanks. So external HIUs are a very easy solution to both of these issues. And what we mean by external HIUs is moving the HIUs from the utility cupboards in the dwellings and putting them in areas where they're accessible from communal areas. So to kind of the corridors in a flat, so you'd have an extra door with the corridor which you'd open, which the HIUs would be in there. The best way to optimize the design to minimize the extra floor space required, you could put 2 HIUs per floor per cupboard. You can also then set up a multiple riser, set up with the risers actually running up through these HIU cupboards. So you're going from long terminal run pipeworks to all you need is kind of at most half a meter of pipework from your multiple risers to each HIU. And the access is now possible without reliance on residents. So all you need is the riser key, which the operator will have. So access is instant to 100% of HIUs. And another benefit to this, which I haven't touched on yet, is that you're actually also removing all high pressure pipework from your dwellings. And that really has opens up a whole lot of possibilities with regards to design from a hydraulic strategy as well. And this would look, something a bit like this. So whereas before we had one riser going up with horizontal pipework on each floor, you've now got basically vertical pipework only. So these risers running up, and about 2 HIUs. So 2 HIUs per floor per riser, which means that it's not kind of one riser per flat. It's one riser per 2 flats where this is possible. Having an odd number of flats on a floor is going to make slightly complicated things, but definitely doesn't, in the grand scheme of things, doesn't kind of swing things out of favor of these. So this is just again to go back to CP1 2020. It's now a minimum requirement to minimize your network length during design, and the optimal approach from a network length perspective is to have multiple risers with externally accessible HIUs. That's the way to minimize your communal distribution pipework. So you've got rid of all your laterals, and it also removes is the best way to minimize your terminal run pipework. You can see that. So this is a diagram taken from new CB1. It shows the impact of both the HIU location within the flats and also the impact of lateral pipework compared to multiple riser pipework. So if this is kind of given all of the operational benefits and the also kind of network length benefits we've been discussing of HIUs, externally accessible HIUs. Sorry, Gareth, next slide, please. So why aren't we seeing this, and why are we struggling to implement this throughout the industry? And there are two real reasons, two main reasons. The first one is that in the kind of the sales market in the UK, the HIU area in the utilities cupboard counts as part of the sellable area of the flat, and it's really not very clear how removing this area from dwellings is best incorporated to the overall financial side of the development, the overall kind of the studies and the analysis. Typically, the kind of discussions will say, "Oh, you're making dwellings smaller. That's going to reduce the amount of money we can earn by selling the flats," and that historically has been where a lot of conversations have ended. The other main issue, or the main challenge that we see, is that you really need the decision to be made, and you need engagement from all parts of your project team at a very, very early stage of the project. This needs to be sorted out before the building layout has been confirmed, because once that gets confirmed, it's difficult to add in extra risers and start reducing dwelling areas once they've been fixed to add this in. So whilst a lot of conversations we've had have been very kind of positive, and everyone is well aware of the benefits of what this could have, a lot of the time, by the time that discussion's had, it's already too late. So what my research project, the aim of that was to do, was to investigate the life cycle benefits, so to put some numbers to the impact of accessibility and the impact of network length, and compare this to the impact of reducing your dwelling area, or by having this extra non-sellable or non-dwelling area within your development. And that was done through a net present value assessment, which I will come on to a bit later, but before that I'll hand over to Claire to discuss a bit from the architect's view how externally accessible HIUs are viewed.
Yeah, thank you. So yeah, so I suppose from an architect's view, it's possible to include externally accessed HIUs, and really we try and encourage it on our projects at Levitt Bernstein, because we know the benefits that can be had. But as part of that, I suppose some of the key things that we look for in terms of what's included, we need to understand, is it included in the client's brief or their ERs, because that's a really helpful point for us to start from. If we can see it in briefs and ERs, then we can, from that kind of really early stage, be thinking about it. And then leading on from that is discussing the need to access externally from RIBA stage 2. So I think what we're finding is, if it's left later than RIBA stage 2, then we're sorry, can we go back a slide? Just sorry. Yeah, thanks. Yeah, if it's RIBA stage 2, then we can really integrate it in our design. Any later than that, and we need to reconfigure kind of flat layouts, and it doesn't always work in the way we would hope it to. But it doesn't need to be a fundamental change to the design. So you can see these two flats on the right show a HIU located in pretty much the same location, but one's externally accessible and one's internally accessible. So actually, by switching the way a door operates on an external wall, you can actually turn it external without changing your building layout. So these are kind of flexible layouts that we encourage at Levitt Bernstein to try and make sure that happens. But it does require thought and planning to make home layout work out. So you can't just put it anywhere, because it does mess up how your bathrooms and your kitchens and things are laid out. So we pop on to the next slide. Yeah, so here's two examples of dwellings. So what we usually find is the dwelling at the end of a corridor or a walkway is the trickiest to kind of squeeze in, because you'd normally have a door at the end of the corridor, and instead you'd have to kind of turn a right angle to enter your front door, so that you could have your HIU still accessible from the corridor, because you end up with limited space on the corridor. So it does mean a little bit of a tricky one at the end of a run, but you know, there's multiple options for doing that. We acknowledge that it's kind of more economical to pair the HIUs between dwellings, but what we find is actually this makes the dwellings slightly harder to lay out. So for example, if you took the plan on the right, on the left, sorry, and you moved that HIU behind the bathroom, you'd end up with a very awkward bathroom shape, or you'd need to take space out of the bathroom to put the HIU. So we're finding that mid-plan tends to work best architecturally, but actually if we're talking engineering and the research that Tom's done, then you would try and pair them and put them in a riser. So that's kind of things that we're working on architecturally to make sure those layouts work out. And then if we pop to the next slide, something that we've been finding is not only that the gross to net ratios between corridors and flats are kind of always questioned, but looking at different types of dwellings. So if we look at an accessible home, a wheelchair accessible home, you actually need much wider frontages, much larger bathrooms, much larger kitchens, and this can be slightly problematic for squeezing that HIU cupboard in, because you end up with a limited frontage of your building. Although these are unusually shaped plans, they're actually slightly oversized because of that. But typically, if the plan was a square plan, we actually struggled quite a bit to get the HIU located on the external wall here, just because the frontage of the building, we needed set widths for our bathroom, our hallway, and our kitchen. And we couldn't squeeze those down anymore. But it is possible, but it does require that kind of thought to get it in. We're also, a lot of our schemes are dual aspect, so we do need a thermal line on both sides of the building, so we need to insulate the wall, and we're finding the easiest way to do this is to include the HIU inside the dwelling and keep the external wall line on the outside, so that we're not costing more in building that cupboard. So the only cost difference is the door. It's not, and you've got a little bit of an internal wall, but that would happen anyway inside a dwelling. So in order to keep costs down, we kind of keep the thermal line on the outside. And then the only last thing to kind of consider with dwellings is that we're working to nationally describe space standards. So the government set space standards on dwellings, and their minimum sizes of dwellings. So it means that we're often pushed to work to the absolute minimums. So whilst the most obvious thing would be to increase the size of the dwelling to fit that HIU cupboard in, we can't always do that. So we are looking at stealing space from the living room, because that's the only space we're allowed to steal from. So bedrooms are set sizes, bathrooms are set sizes, kitchens are set sizes. So we can only steal out of that living space. But back over to Tom. That's all from me.
Thank you, Claire. So now going on to the research project that I ran. So as I mentioned, it's a net present value study. So looking at the life cycle costs of externally accessible HIUs and comparing that to the conventional network layout that we saw at the start of this presentation. So I did that over 30 years with a 3.5% discount rate, assuming that any reduction in dwelling area would cause a reduction in revenue from sales. And so the main things we were looking at were the network length from a capex, a heat loss, and a carbon cost perspective. Then also looking at the cupboard cost, so the extra insulation, the doors, locks, also extra connections longer connections between the HIUs and the flats. and then looking at the cost of access maintenance and the impact of the ease of maintenance on efficiency. Before we get into the, so next slide, please, Gareth. So before we get into the results, just a few key outcomes of the research that we found. So from a network length perspective, external HIUs allow you to reduce your network length by about 65%, which is absolutely massive, and also has a large impact from a CapEx perspective, but also you can see from a heat loss perspective, you go from that to around about 90 watts per dwelling mark, which is really on the boundary of that, the CP1 2020 boundary, to down to kind of 40, 50 watts per dwelling, perhaps even lower than that, which means you're very comfortably below that. And also, this is going to have quite a big impact on heat tariff and reducing that and making sure that your heat is affordable for your residents. Access is instant with external HIUs, which means your ability to maintain performance is high, and the risk of resident tampering, although it's not a kind of a huge impact on the conventional layout, you also completely remove that risk as well. But then at the bottom, you see is that it's about 0.3 meters squared per dwelling of cupboard area that you need to find space for and you need to account for in your design. So looking at the results, apart from the most expensive areas in London, so this is the Zone 1, Zone 2 areas in London, external HIUs over 30 years are a net benefit to from a cost perspective. So it's really only these the most central areas, which are kind of, whilst there is some residential buildings in there, a lot of that's kind of more of a commercial area, but in several of the areas of large development currently, both in London and outside of it, this over 30 years is a benefit from a financial perspective. So you can see this within London, and then if you go outside of London, the benefits are basically everywhere outside of London. You are getting a net benefit over 30 years. So that's the reduction from a CapEx from your reduced network length, and from an OpEx from your reduced heat losses and from your reduced costs of servicing outweigh any reduction in revenue from sales. So the key takeaways from this, I think I'd like to finish up on. So as I've been mentioning throughout, external HIUs remove the access barrier to maintaining good network performance, and they also reduce your network length by about 65%. And these operational benefits are kind of a fairly significant way of enabling a lower heat tariff, and also much lower overheating risk as well. So much you're improving resident comfort, both from a financial perspective and also from a physical comfort perspective. This is a very good way of de-risking your design against both pressure risks by removing that high pressure pipework from dwellings, and also against pending legislation, so the BC and the heat network market framework coming through. And as you saw in the two graphs just now, apart from in the most expensive areas in the country, so in a vast majority of the country, external HIUs are likely to offer life cycle cost benefits over internal HIUs. But the one thing, and if this is something that you're kind of considering or would like to include on future projects, the decision needs to be made pre-planning kind of as early as possible to specify external HIUs before the building layout is fixed. And that's everything from me, so thank you for listening.
Great, thanks a lot for that, Tom, Claire. We've got some questions that have come through through the Q&A. First question, do external HIUs have an impact on the cold water system in the development?
Yes, so quite a significant one actually. From two sides of this. So one, you're decoupling your hot and cold water systems. So you no longer have LTHW running through corridors, which means the heat losses from your heat network are no longer a heat gain into your cold water system. So it's improved cold water delivery times, improved cold water temperatures, and improved comfort from that perspective. And it also, especially within London, the Thames Water requirement of accessibility to water meters, which is why we see typically the several parallel runs of cold water pipework in developments. Those water meters can be moved into the HIU cupboards, which means you can still access your meters communally, but you can now have one communal cold water pipe run running throughout your each floor, and that's another fairly significant saving in terms of pipework, because you're removing a lot of your cold water pipework and turning it into one communal lateral run from several individual runs.
Yeah, just note on that. We ran some numbers on that, and it was as much as £300 per dwelling in terms of reduced cost by going down that. Which that wasn't factored into your analysis, was it, Tom?
No.
Okay. Second question: how do external HIUs change the construction and commissioning process?
So on top of just the financial benefit of reducing the amount of pipework, less pipework also means during the construction process it's fewer deliveries to site, less waste, fewer faster install time, less works, less hot works. So from a kind of a construction safety and program point, it's really makes things quite a lot easier. And then during the commissioning process as well, the fact that you have access to HIUs even after you hand over the dwelling means that where you're tight against handover deadlines or you're running in phased handovers, you can continue to optimize your commissioning process and also manage your water quality and water treatment, which I know is going to be discussed later on. That all becomes much easier because you can access your entire network even after handover.
Claire, do you have anything to add on that one?
Well, just in terms of construction, I suppose we don't see that it changes construction other than just that external access door, or it could be an internal riser door if it's got a corridor attached to it. So really it's a pretty simple process from our point of view. It's just about the location.
Another question: what does removing high pressure pipework from dwellings do to your hydraulic strategy?
So I kind of touched on this ever so slightly throughout the presentation, but external HIUs mean that you have there's no LTHW pipework in dwellings. So when designing from a hydraulic perspective, the pressure risk to residents is almost completely removed because you no longer have that pipework in ceiling voids in flats. So the pressure kind of delimiting factor is now pressure kind of equipment pressure ratings rather than safety. So if you look at typical ESCO, we'll say above 6 bar, that's kind of their limit of where they're comfortable having of pressure in dwellings. You can push that up to 16 bar quite easily with when you're just looking at equipment pressure. So that's an extra 10 bar before you need to start thinking about hydraulic brakes, which I think we looked at the numbers as an extra. It's about 25 floors vertically before you need to consider putting in heat exchangers, which means so that's a capex saving your plant room, and also is extra space that you're reclaiming from that can be used for communal or commercial use.
Question from Gabrielle Firestone, Camden Council. I think you touched on this, but what's the work involved to move an HIU from inside a property to outside? What kind of cost is it? So where are the costs within this?
So the main cost really, or the main cost in my analysis was the actual value of the 0.3 meters squared. That's a kind of especially within London where the price of land is very high, that even kind of such a small area can have quite a significant impact. There are some costs also associated with the cupboard. So you've got an extra door, an extra lock per cupboard. But from the construction point, all of those cupboard costs are quite significantly outweighed by the reduction in pipework length and the capex saving from not having to procure and install that pipework. So the only kind of real downside was that the value of that land, and that's why the kind of the discussion about how to incorporate that that value into the overall financials of a development are the answer to that question would really unlock this. Kind of if there was a way of reclaiming that value somewhere else, or increasing the value of the dwelling to account for that reduced area, kind of per square meter, that would really kind of unlock the doors to roll this out.
Great, thanks for that. Just there was a question from Jason Crawford, City of London. With residents who won't give access, if maintenance issues are impacting other residents through higher charges, can you place non-access residents on a higher tariff? I'll respond to that. You need to manage it very, very carefully. There are people who've been through that process. More than happy to have a discussion about that. Tom, Claire, thank you very much for coming on today. Thanks for your time.